everybody, and thank you for the opportunity to present OpenAtlas here within this workshop. My name is Stefan Eichert, and together with Alexander Watzinger, we are, as you can say, the two-man army behind OpenAtlas. It's a database system for archaeological and historical information. And the whole thing started more than 10 years ago when I was working on my master thesis, and I needed a database for several hundred cemeteries all over Austria. And then it continued, and for a couple of years Alexander is also a member of our two-man army. And maybe some words on the evolution of the whole project. Like 99% of all archaeological databases, unless they are Excel sheets, it started as a Microsoft Access database. And it was a relational database. Sooner or later I ported the whole thing to MySQL backend. And then with my PhD, I worked on other data, not only from archaeological sources, but also written sources, historical sources. And I worked with information on actors, on events, on monuments, on archaeological sources. And sooner or later I stumbled across the CIDOC CRM, and it turned out to be something that actually I was looking for, but didn't know that I looked for it. So then I spent lots of hours online and did lots of research on whatever was available online about the CIDOC CRM. And then I transformed the data model of the existing database to a data model, an object-oriented one, using classes and properties of the CRM. For some years now, Alexander has joined our team, and I promised him to mention that he had nothing to do with the Microsoft Access database. Since Alex is on board, he moved the whole thing to a new level, especially from a technological point of view. It's entirely open source now, web-based, but he will tell about the details later on himself. And here you can see some of the projects already using the software, the system. They also cited at our website. And as the main topic of the workshop is how we map our data with the CIDOC CRM, I want to show you one example that we often find in our database that combines evidence sources from various disciplines. In this case, it's a church from the Middle Ages, founded in the 9th century. We know about this church from written sources. It still exists. It's a physical object in our world right now. And there is a churchyard around it, and archaeologists came and dug some holes, and they found bones and grave goods and swords and so on. And this is a case that really often exists in our database, and we model it something like that. It's a very simplified version I will show you now, but probably we can discuss it in detail in the afternoon. The church itself is mapped as an entity of E18, physical object, if I'm right. Physical, yeah. And of course we could go more into detail and use subclasses that fit better to the entity itself. But our database is not designed for CRM specialists, but for archaeologists, for historians who have no idea what the CIDOC CRM actually is. So we try to offer them a user interface where they can find a workflow, easily enter their information. They do not have to think about the underlying model. And by sticking to the top levels of the classes, we try to avoid certain mistakes. So yeah, what else is mapped in our database? Every physical thing can have a location mapped as a place. We use PostgreSQL and PostGIS, and along with the location of this physical object, we also attach GIS geometries that are supported by PostGIS. Of course, we allow for customization, for classification using types that can be subtypes of other types. So there is a hierarchical tree actually for classifying the objects in our database. And as I mentioned, we've are dealing with sources from various disciplines. And in this medieval charter, you've seen on one of the first pictures about the church. This charter mentions that the church has been traded between the king and the bishop, and we map things like this within an acquisition event, E8. And here you've got the bishop and the king, and they meet at the castle of the king, for example, which is also mapped in the database. The gathering takes place at the castle of the king, but there they decide that they trade the church and it changes the owner. And all these entities are mentioned in this charter from the 9th century, for example, that refers to all these entities. And as I mentioned before, also lots of archaeology took place at this church. Archaeologists, they don't like to deal with text so much, they prefer pictures or really digging out stuff. And the church is composed of various other components, and some of them are the graves that are at the church. They also mapped as E18 entities in the database, and they again can be composed of archaeological components, in this case the backfilling of the grave, the skeleton, again mapped as E18 entities along with the location, along with GIS geometries. And these archaeological structures can again be composed of stuff like grave furnishing, in this case sword, pottery, spurs, so we know that the person buried here probably has been a knight, a rider, a warrior. And again, these objects can be classified using types and subtypes, and also material. What we also do a little bit outside of the CRM is that we can attach values to properties. So in this case, the spurs are made of bronze, so they consist of 90% copper and 10% tin. And this was just a brief and very simplified example of the underlying data model. What you see here is a graphic that Alexander has created, showing it's already simplified the data model and how we map our network within the CIDOC CRM. And of course now there is not enough time to discuss it all in detail, but I guess in the afternoon we will have the opportunity for that. And now it's a pleasure for me to hand over to Alex, and he will now tell you more about the technical background and show you some of the stuff in the demo version.
So hello. I would like to talk about software and how it is linked to CIDOC CRM. So the software is open source and it uses and is built on other open source software. It is written in Python 3, that's the main language. It uses the Flask framework. It runs on an Apache web server, and it uses PostgreSQL as a database. And there are some JavaScript libraries for visualization of the map or the network. So one of the first things we did was to take the CIDOC CRM specification and put it into our application. We imported it into the database, so all the classes, properties, and the rules how to link them. Then we made the CIDOC CRM specification browsable, because at this time at least the official documentation wasn't very helpful or useful. And I will demonstrate that in a moment. After some time, we noticed that we made mistakes. We were sitting, discussing the model for hours, and mistakes happened, and so we implemented a link checker, which I will also show, where you can check if a link is valid from the CIDOC CRM point of view. After a while, we noticed we still made mistakes, and so we integrated into the software that every time a user makes a link, it will be checked also. So if there is something wrong with it, the application will tell you. With the next version, which will be released in 1 or 2 weeks, we also implemented a feature which checks all existing links, because there can be the case that you import data from other sources, and so this can be checked too. Here are the links again, and thank you for listening.